Let's end this once and for all. To all of my nurses, you need to hear this from the laboratory. Hemolysis happens at the time of draw.
All right, so go ahead and give Marilyn a follow if you want really good content on lab side of healthcare. But let's talk about the blood drawing straight off the patient. Why are we hemolyzing these samples? What's actually happening at the bedside so that we can figure out how not to hemolyze these samples? So let's get super pedantic here. You want to look up the Hall-Petch relationship. It's not necessarily a law, it's a series of things that come together, but generally the idea is that the smaller the material, the more durable it becomes. I don't think it's actually the shearing or ripping of the cells due to the bumping or cutting from the needle, let's say. It's not really the turbulence that caused the hemolysis, although this is debated. It has more to do with the pressure changes due to what's causing the turbulence. Because there's turbulence all over our body. There's shear force turbulence from your heart, from your SVC, from your IJ. Just look at large vessels. You're going to see turbulence all over that blood flow. However, what is guaranteed to hemolyze that sample is something called cavitation. Cavitation is rapid pulling of fluid or cells due to the rapid negative pressure or decrease in pressure. Same thing happens with barotrauma. If you've heard of the bends, diver sickness, it's when we go from a high pressure environment to a low pressure environment too rapidly. Why is that so dangerous? We get what's called nitrogen poisoning. Well, how do you get nitrogen poisoning? We're not inhaling more nitrogen. It's because it's cavitating the nitrogen and forming these bubbles, and we actually cause an air embolism. And so these pockets of bubbles are forming all over our joints and our bodies, and that's what the cavitation is what causes the complications and these bubble formations. And so we're doing the same thing with our blood. When we pull too hard from the syringe and we hold it, when we pull too hard from the vacuotators and we hold it, that's where the cavitation is happening in the hemolysis. Okay, so then how do we solve this issue? When you're using the syringe to draw blood, you want to pull, pause, and pull very gently. You want to release that negative pressure, give that blood time to fill at the tip of the catheter. Also, when we're pulling from that vacuotator tube, we want to vent that top and then close it back up, especially when it's not filled. As soon as possible, you want to vent that top, close it back up, and then send it over, because that blood is sitting in a non-homeostatic environment of pressure. The longer we keep it in that tube and the longer we have it sitting before it gets to lab, the more likely it's going to hemolyze, because we've given it and put it in a sustained low pressure environment. Remember, blood hemolyzes immediately after it leaves the body. Our job is to delay that hemolysis until it gets to lab.